Hi, in this video we'll be looking at the concept of superfields in Studio. Superfields allow you to create a data model that can access multiple companies, databases, schemas, entities. As an example, let's have a look at a system called SAP Business One. You can see that it has a superfield called Company, and when I select on it, I can choose between two companies. Here's a user-friendly name for the company, and here is the database name. You can see there is an AU and a GB. When I select a particular company and create a query, and let's preview that and look at the SQL, you can see that the table name is prefixed with the company that we selected. If I went in and then queried over another company, for example, the GB company, and previewed it again, you can see that it's now prefixed the table with the GB database. If you create superfields over a data model, you can also start doing things like consolidating the databases. So in this case, I've held down the control key and selected both of them, and now I have both databases consolidating into a single value. I can then also bring company out into the outputs, and now we have the two companies. And if we look at the SQL again, you can see the engine has produced a union OR to combine those two companies together. Let's have a look at this particular example in SQL Server Management Studio. You can see that SAP Business One had a database which is called Common, and that's where it kept a list of all the other companies that it had access to. So this particular data model's connected to Common, got out the list of companies, and use that to then prefix the tables to get access to these. In this example, I'll be looking at a slightly different scenario where we have multiple databases and we'd like to connect to one of them and then scan the whole system looking for other databases. Here's the example that I've already prepared. Just going into this one here, and you can see that I've prepared a list of databases. Instead of displaying the raw database name, I've got a code and a description. This list includes all the databases that are on my system. When I select one of them, I can then query from it, and just like before, we're going to prefix the table with the database name. So in this example, we don't have a domain database that has a list of the companies. We're simply going through using a bit of SQL logic to step through looking for any valid database that has a particular table that we know pertains to this system. Let's open up Studio and see what steps were required to introduce this logic. First of all, come into the processes and have a look at on startup. You can see I have a number of processes here. First one required to introduce superfield logic will be something like this. This is the SQL that I've created to scan the databases to look for anything pertaining to this particular system. Let's copy this out and paste it into SQL Server and execute the SQL. You can see it's creating two state values, one called DB SQL, which is a SQL statement that produces a list of database codes and descriptions. If I execute that, you can see here we have our default company, and here are the others with a code and a description, and also the original database name from which they are sourced. The second state value in this example is producing a comma delimited list that we'll use when we select companies, when we select superfield values, to make sure that they're valid. We're getting a list of the superfield values. There was no good name in the databases that we're scanning. For that reason, I went into the databases and selected their properties and then went to extended properties, and I've created an extended property called code and description. This particular SQL statement, when it's scanning through them, it's looking for these extended properties, and if they exist, it's using those, and if they don't, it's defaulting to the raw database name. The reason why I did this was because when users are selecting a database, they prefer to use something with a user-friendly name and a database independent code. In this way, we could rename the database later on and not have the reports broken, because the reports are against this code here. Let's just have a look at this SQL statement. It can be adapted for other systems where appropriate. You can see there's a whole series of declares, and then we're scanning through all the system databases, and we're using a cursor to then build up that SQL that we saw down here, where we union each database onto the end of the next. And at the end, finally, we place those into memory. There is a bit of additional logic up the top so that we could introduce a property into the list so that if we wanted a subset of these databases, we could put in a comma delimited list of database names so that it would not pick up them all. I'll discuss this later on. Let's go back to Studio. So the first step was to run this list, get the list of the databases and valid databases. Then the next step would be to create a virtual table that wraps those union SQL statements up into a list. We're going to use this later on in a lookup. And then finally, we have the database prefix. I'll describe what this does later. Next, click on the product at the base and come to the property called Super Field. You can see that I've already enabled this Super Field logic. This is the code of the Super Field, and you can see that we have a lookup associated with the Super Field. This goes to a lookup table that displays the code and the description associated with the company. By default, I've set the default value to default. To validate that the user has entered the correct company, we need to set the validation method. This step is very important because if they enter in incorrect values, we'd get SQL statement errors. You can see I've used the state value list, and in this particular example, I'm using the contains method. This list will be resolved into a comma delimited list. So basically what we're saying is they have to enter a value that's in this list. After you've enabled the super field, the next step is to create a lookup. So if I come into tables, you can see that I've already created a lookup, and I've reused that state value that was originally created in on startup. So it's reusing the SQL statement that we produced before. And it's just wrapping them in commas so that it becomes a virtual table. So we have our code, our description, and then the original database name. Now let's have a look at the tables. If I come to this table called employee, you can see that the employee table's been prefixed with a state value called db prefix. What this state value, which is a type of macro, will do is take whatever company code that's currently selected and turn it into a database mode. If we come back to on startup, you can see it has nested state values. So the first one is going to take the filter company details, which will be some sort of code, and place that into here. And then it's going to come out to the next state value, and it's going to look for the database name. It's probably best if I just show you what this looks like in memory. Let's go back to the query builder. And you can see here I've got employee, and I can come into the product and right click on it and click on debug and select state values. These state values were read into memory on startup. You can see we have our SQL statement I was talking about earlier, which helps produce the lookup. The next one was the valid list of companies. So the cursor SQL logic built up this list here. So when the user enters a code or types in a code, it has to be one of this list. Then we have a list of each company and their details. So the database default, its code is default, description, and here's the database it's going to. And the same for the next one and the next one. So that database prefix on the front of the table was taking the code and then putting db underscore on the front of it, and then we're looking for the database name. Looking at the state values in memory helps you to understand what's going on internally. Next, I'd like to discuss how we can restrict this list. If we have many databases on the system, we want to allow whoever's setting up the data model to restrict it to a smaller subset. What we can do is create a global property. Come back to Studio and click on Product and come to the property settings. I open up Global. You can see I've created a property and the property code is DB access list, and it has a description and a comment about what it is and the data type string. When the data model is deployed, this property will appear in site setup. You can see here I've selected this test data model, and here's our list, database access list, and the comment's just explaining what we need to do. But this is left blank. By default, it'll pick up all the databases that have a particular table in them. We could restrict it to a subset by just typing in the database names that we'd like to reduce it down to. Let's have a look to see how this logic here is working in our example. If we come back to the SQL that loads all the databases, you can see that there's a state value reference in here, which I blanked out earlier. What it does is it takes the site setup values that we've entered in, if there are any, and places it in here. And then later on in the SQL logic, it'll look at that list, make sure that whatever databases we're picking up are part of that list. And that way we can exclude particular databases. Next, I'd like to talk about the importance of having some sort of default. In this example, when we're scanning through the databases, it's looking for the default database. The default database is defined by the connection details. The connection details are defined in client setup. The reasoning behind this is that if you connect to a particular database, we'll use this as the default. And the default's quite important because if you create a standard report pack, you may be tempted to tie the report pack into a particular company code. But if when deploying it to production, that client or that site doesn't have that code, all your reports will have to be adjusted. In this way, you can create the reports against a default company code and deploy them to a site. And then, depending on that site, you could then connect to a different system. Then on site, depending on the connection details, those reports could be redirected to a particular database. What we want to do is avoid hard coding reports to a particular code that doesn't exist on all systems. In summary, here are the steps for creating a superfield. In Studio, go to the Product tab and enable the superfield properties. Make sure that you always set a default value and you have validation logic. Next, come to On Startup and define your state values for collecting information about each company and create a state value validation list. Don't forget to create a table that will feed the lookup selection for the superfields. Then in most cases what you'll be doing is prefixing all the tables in the system with the company logic. In this case I've used the search feature to look for DBO, for example, and replace it with the prefix code. If you're on another system such as Oracle, the same concepts apply. It's just a different SQL statement to seed that initial list. Once superfields are created, a lot of functionality starts becoming possible. And in most cases, users are interested in the concepts of being able to port over multiple systems and also introduce new logic like consolidation across companies. It's still possible to secure access to particular companies. So if I came into a user and select the test data model, you can see there's a table restrict access, and in here we can restrict access to particular companies. This has been a brief overview of how to implement superfield logic in Studio.